Okay, today we're going to focus on double replacement reaction. So again, things that we want to have out to help us: periodic table and your flip chart. Okay, so using our flip chart first on a double replacement reaction, we're going to go ahead and flip the page so we can see our example. So this is when ions are exchanged between two compounds. So you have two compounds on the product side. All right, and what we're going to do is we call how we figure out how they exchange is we kind of do this belly button rule, where the outies go together and the innies go together. So you're not going to have, so A will not pair up with C because they're both positively charged. So these are ionic, so we're seeing ionic bonds here. So B will go with C. Notice when you write the products, the metal's written first. The positive ion gets written first, always. It doesn't really matter which one you do. You can do the innies first, then the outies. It doesn't really matter, as long as you get as long as you match them up correctly, and then you are writing the metal and the non-metal. Okay, so we have an example here that's also balanced. So we'll put this to practice. So this is our guide to reference. All right. And we're also going to be using our periodic table to look up the charges to get the correct formula. So in this example, this one we'll do the first one. We have barium chloride plus sodium fluoride. So we're going to do the ini-outie rule. So we know that barium, we'll do the outside first. Barium is an outie, will connect with fluorine, which is also an outie. And then chlorine, an ini, will connect with sodium, which is the other ini. Okay, so that's how we're going to do this. But now to get the actual products, we're going to do a little bit work off to the right where we have to do the crisscross method. So we'll start off with the outies first. So barium and fluorine. So we're going to go off to the right here and write Ba and F. Looking at our periodic table, barium is down here and it has a +2 charge. So we'll write a +2 above it. Fluorine is over here and has a -1. So we'll do a -1 charge. So remember, we crisscross the numbers. So the 1 to the barium and the 2 to the fluorine. So the first product will be BaF2. So Ba and F2. No plus, and then we'll predict the other product, which is our innies, Na and Cl. So we'll look those up. So you have sodium, Na, and Cl. So on the periodic table, here's Na, sodium, it gets a +1 charge. Write that above it. Chlorine, which is Cl, is right here, has a -1 charge. So we crisscross them down, so it's a 1 and a 1. So in chemistry, we really don't write the ones. That number just implies that's how many atoms there are. So it's just NaCl. NaCl. So now what we want to do is balance this. So let's use a different color. So just to make sure, again, some of us can look at this and figure it out. Others, we might have to do the inventory. So I'm going to take you through the process of the inventory if you need it. We'll list out all our elements on the reactant side. There's 1 barium, 2 chlorines, 1 sodium, and 1 fluorine. Now let's go to the other side, the product side. Try to keep them in the same line. Barium, there's 1. Chlorine, there's 1. Na, there's 1. And for fluorine, there are 2. Okay, so the bariums are balanced. The chlorines are not balanced. You have 2 on the left and only 1 on the right. So let's put a 2 over here to get it even. So now that 2 as a coefficient gets distributed to the sodium. So that actually gives you 2 sodiums, and 2 times 1 chlorine gives you 2 chlorines. So bariums are even, 1 and 1. Chlorines are balanced, 2 and 2. Sodiums are not balanced. We have 2 on the right and only 1 on the left. So we can't. So since we can't take away here, we got to add a coefficient. So we're going to add the number 2. The number 2 as a coefficient gets distributed to sodium and fluorine. So 2 times 1 sodium gives you 2, and 2 times 1 fluorine also gives you 2. And look what happens. We are completely balanced. Bariums 1 and 1, chlorines 2 and 2, sodiums 2 and 2, fluorines 2 and 2, completely balanced. Any empty spaces we fill in with 1s as placeholders. So there you go. So there is an example on how to predict the products and balance a double replacement. And I apologize if this was off screen. Alright, but there's the work so you can see how I got NaCl. Same process. Look up the charges, crisscross them down,